All right, let's talk about matter. What's the matter? Eh? What's the matter? Matter is just physical stuff, and it's made up of atoms. Atoms are made of protons, neutrons, electrons. Those are made of quarks. So, I mean, you can get really granular, but when we're talking about stuff, we're generally talking about atoms. I mean, we'll talk about protons, neutrons, and electrons, but we're generally talking about whole atoms. So, we can classify matter in a couple of different ways. First, we can talk about elements. And an element is one substance that has a certain chemical property that's not combined with anything else. And if you were to change the atom, you would no longer have that element. So it's defined, technically, it's defined by the number of protons you have. And if you have that number of protons, you are that element. So if you have 8 protons, you are oxygen. If you have 7 protons, you are nitrogen. If you have 9 protons, you are fluorine. So the element you are is determined by the number of protons you have, not necessarily the number of electrons you have, because that can change, but by default, a neutral atom will have the same number of protons and electrons. The number of neutrons, as we'll see, can vary. We can talk about molecules, which is a combination of 2 or more elements, and this is always whole number ratios. You cannot have half of an atom. We talk about ions, which is a neutral atom that has either gained or lost electrons. If you lose electrons, you become positive because electrons have a negative charge. So if I'm losing negative charge, then my charge becomes more positive, which it sounds counterintuitive, but it actually makes sense. So my neutral atom loses electrons, it becomes a cation, positively charged. Gains electrons, it becomes an anion, negatively charged. And then we can talk about mixtures, which is a combination of 2 or more elements and or molecules. So it's things that are physically together but chemically distinct. So if you think about soda, for instance, soda is water with dissolved compounds like sucrose and flavoring compounds and things like that, and carbon dioxide. But if I have a sample of Coke and you have a sample of Coke, and we look throughout that sample of Coke, we're going to find the exact same distribution of molecules wherever we look. But if you have something like, so I like French press coffee. So French press coffee, you have a whole lot of grounds and particulate in your coffee that you then filter out. You put a mesh filter on top and you push it down. And so you're physically pushing some of the stuff out. And that's how you can generally differentiate between a homogeneous mixture and a heterogeneous mixture, is that a homogeneous mixture cannot be separated physically, but a heterogeneous mixture can. So, let's talk about states of matter. Solid, pretty straightforward. Ice, you got a definite shape and a definite volume. So it has a defined shape, it has a defined volume. Liquid has a definite. I switched these. A liquid has an indefinite shape and a definite volume. So it takes the shape of whatever container it's in, but a liter of water is a liter of water. And then gas has indefinite shape, indefinite volume. It'll fill the container that it's in. There are other states of matter. 2 of the noteworthy ones are plasma, which is basically you've heated up stuff so hot that you've basically stripped all the electrons off, so you have a bunch of negatively charged electrons and positively charged nuclei that are just kind of streaming around. It's very conductive. It only happens at extremely high temperatures. You have supercritical fluid, which basically just means there's no partition between liquid and gas phases. It's pretty useful in industry. They use it for decaffeinated coffee and doing dry cleaning. And there's also this Einstein-Rosen condensate, stuff that you are never going to encounter in everyday life that doesn't really matter. Solid, liquids, and gases is pretty much where it's at. So we can break down the properties of any given molecule or element into physical versus chemical properties. So physical properties are basically the descriptive properties of the compound. You say, okay, here's the molar mass, here's how much it weighs, here's the melting point, here's the boiling point, and these are physical properties of water. Like heat of diffusion, viscosity, things like that. So it's describing the compound or element, right? Chemical properties has to do with its reactivity. So for instance, water will react with sodium metal to form sodium hydroxide and hydrogen gas. So that's one of the chemical properties of water, is that it is reactive. It is also technically both acidic and basic. It's what we call amphoteric. So those are going to be that's the difference between physical and chemical properties. We can also classify physical properties as extensive or intensive. The difference is an extensive property depends on the amount. So if I have 5 grams of stuff and I get 5 more grams, so now I have 10 grams of stuff, my extensive properties would change, but my intensive properties would not. And my PowerPoint seems to stop. There it is. So intensive properties are stuff like melting point, density, temperature. Okay? So the melting point of water, whether I have a single ice cube or a glacier, the melting point of ice is 0 degrees Celsius. The density of water is 1 gram per milliliter. It is dependent on temperature, but it's technically an intensive property, right? If I have a gallon of water, or I look at the ocean, the density of water is going to be the same. The temperature of a thing. If I have a cup of boiling water, or I go to a caldera and then I have a billion gallons of boiling water, the boiling is still, or the temperature is still 100 Celsius. So those are independent of amount. Most of the properties we look at are intensive. Extensive properties are going to be stuff like mass. If I got more stuff, it's going to weigh more. Mass and weight are not the same thing, but it's going to have more mass, right? If I got more stuff, it's got more mass. Volume is an extensive property. If I got more stuff, it takes up more space. Heat content, how much energy is contained in an object, that is an extensive property. If I have more stuff, it's going to have more energy, potential or kinetic. And that's like the 2 big defining lines. So those are kind of the classifications you need to think about for matter. Is solid, liquid, gas, right? The state. Is it an element by itself? Is it a compound? Is it a mixture? If it's a mixture, is it homogeneous? Is it heterogeneous? Remember, the difference is homogeneous is equally distributed. Homogeneous is unequally distributed, and it's going to be, you can generally filter it physically. And then you have physical and chemical properties. That one's pretty easy to tell apart. And then in your physical properties, you have extensive and intensive properties. So, be thinking about these things to understand these broad categories of classifying matter, of properties, extensive, intensive, and things like that. So whenever you're looking at a list of physical properties, ask yourself, is this intensive? Is this extensive? And again, it's usually pretty easy to figure out. If you double the amount you had, would that property change? If it would, it's extensive. If it wouldn't, it's intensive.